Hello and welcome to another episode of Microchips. In this episode we look at the 3-cell battery BMS protection boards that I purchased from eBay that I unpacked on a previous video. So today we're going to be connecting them up to 3 lithium cells, checking whether they're charging, checking whether it's actually producing the correct voltage, checking whether things actually get too hot, basically just giving it a once over before I think about putting it into a project. So here we have the 3 lithium battery holders. They should take a 18650 battery. So we'll start by connecting them up. I have all my tools ready to go. And the trusty gas soldering iron. So we'll refer to the circuit diagram that is provided on the eBay page, and we will connect it up according to that schematic. So here's the schematic quickly on screen. So battery negative goes to B minus, and then we must join the positives of battery 1, battery 2 and battery 3 to the necessary parts on the board, but we must also put the batteries into in series. Nearly said serial then. So we must put the batteries in series as well, but we need to take the tap off in between the batteries so it can balance and monitor each battery as it's charging and discharging. So what we'll do is we'll just connect up all the batteries to the board. So there's the first battery container connected, the B minus and battery 1. Tin the wire up for this one. Now that should put the second battery into series. And that needs to go, positive of that needs to go onto B2. So we'll tin the B2 connection. And we'll connect it to the board. And the last battery holder. So the negative needs to go to battery 2, and then the positive onto B plus, and that puts all 3 battery holders in series, but also tapping off in between each battery for the battery monitoring. A nice bit of tinning on that. Tin the wire. And that should complete the circuit. It's a little bit messy, but it'll do just for testing purposes. So we've now got some thicker wires. Sorry about the aeroplane. We've now got some thicker wires, and we'll connect those onto the power in and the power out connections. They both use the same connection. So when you apply a voltage of more than 12.4 volts to this connector, it will go into charge mode, and when it doesn't see that voltage, it goes into discharge, or providing the power. So we'll connect these nice wires onto that. Trying not to burn myself with the gas iron. There's a positive and a nice shot of my hand. And there's the negative connections. We won't bare the ends of that for the moment. We'll just tuck them out of the way whilst we do a little bit of testing. Okay, let's install some lithium ion batteries. So I have 3 lithium ion batteries. We'll just check the voltage on them. 3.8 on that one. They are a little bit old, these batteries, but they should be fine. 3.8 on that one. And 3.8. So yeah, they are charged. They have been sat around in a battery holder box for a little while. So let's insert the first battery. And we'll check with the meter. Okay, it's gone down a little bit. And that's fine. It does say you do need to put it into charge mode before it actually starts to work. So we'll install a second battery. And it does help if I install the battery the correct way round. So we've got no voltage there, and then the penny drops that I've actually connected it the wrong way. We'll connect it the right way this time. 3.5 and there's 7.3, so we've now got 2 batteries in series. Making sure the polarity is correct for the third battery. And 11.53 volts. And checking on the output, 11.53 volts. So, batteries are working in series. We haven't emitted any of the lovely blue smoke yet, so all is good. So now we'll attach a barrel connector onto these wires, so we can test it on something that requires 12 volts. Making sure the polarity is the correct way. They are very handy, these plugs. Okay, all looks good, so let's put the batteries in. Just checking underneath to make sure there's no area underneath where I could short to, because I will be using crocodile clips to connect the charge voltage to the power in out port, or pads should we say. So making sure we've got the batteries in the correct orientation, we'll put them in. Check the output voltage, 11.5. So it's providing voltage, which is good. So there we have it connected up to my power supply, which is, you'll see it in a moment, but we can do constant voltage and constant current, and we've got meters on it so we can see exactly what this circuit is drawing in terms of current. So let's check the input voltage again. I'll check the output voltage, 12.9, very good. So now the battery voltages have gone up, so it is now in its charging state. And I was monitoring the power supply meter at the time, and it is topping out at 3 amps. So maybe when I actually place this into a project, maybe we'll have to current regulate this a little bit more. Nothing seems to be getting warm. A quick adjustment of the power supply again, just to keep it within the 12.4 to 13 volt range. And as you can see by the power supply, we're topping out at nearly 3 amps. We've gone into current limited, we're at 12.4, 12.5 volts. So 12.6 on the board. So it is rising very slightly, the input. But what we'll do now, over a course of a short while, we'll take voltage readings across each one of the cells to make sure it's not exceeding the 4.2 volts. And that cell seems to be a little bit low. I don't know why. Is that a bad cell, or is it just balancing there? Nothing's getting warm. So we're coming back to it again after a few minutes. So 12.6 on the input. Near enough 4.2 across the cell. Maybe it's balancing out, maybe that's what it does. 4.2 on that cell. Around about 4.2 on that cell. Not sure whether the actual ends of the battery are dirty or whether that's just what it does. So we'll leave it again for a few minutes. Still 12.6 on the input. Still drawing well over 2.5 amps on the power supply. .2 on the cells, and they don't seem to be getting warm. I wouldn't like to leave it unattended whilst drawing this amount of current, because if it's drawing 2.5 amps, then that means each battery could be getting over 750 milliamps, which would charge it quite quickly. I prefer to have it a little bit lower than that. But across the output, 12.69, very good. Let's disconnect the charging power supply and do a check of the output voltage. 12.2 volts, very good. So it has done something, it has charged the cells. And now we've got 4 volts on that cell. .1 volts on that cell. 4 volts on that cell. So it has charged them. So let's plug it into something that requires 12 volts. I'm not going to do a full discharge test of this. So we'll use the trusty realistic TRC 1005 handheld CB radio. And there we have it. This radio only draws near enough an amp on transmit. I've just noticed that one of the segments is playing up on the LCD, so maybe that's a repair video that we can do sometime, because I've never actually fully stripped one of these radios down. But it powers that up quite nicely. Let's get the meter into shot. 12.2 on the output. All seems to be good. So that concludes today's video on the 3-cell battery BMS board from eBay. Maybe in a future video we can incorporate this into a project. But as always, thanks for watching, and see you again in the next video.